Hello everyone, I'm Jay Cottrell, the Marketing and Communications Manager here at LaserTech. Every Tuesday around 2 p.m. Mountain Time, I will have a conversation with an employee or subject matter expert about solving problems in traffic safety, professional measurement, or other laser sensing issues. You can join us on our coffee break. We are live for about 15 minutes. We are also live tweeting, so if Twitter is more your style, you can join us there. If you have any questions or comments for any of our guests or for LaserTech, please post them, and we'll answer them either in real time or as the subject of another LTI Tuesdays at 2 conversation. And today I have Clint Cowan joining me. Hey Clint, thanks for joining me. Can you tell me how long you've been with laser technology and what you actually do here?
Okay, I'm the product manager for LTI's Industrial Sensor Division. I've been at LaserTech for about 5.5 years. I've worked as product manager for a variety of high-tech companies in the past, primarily in the computer, semiconductor, and mobile computing industries. And I have a BBA and MBA in marketing from Georgia State University.
Okay, so with laser technology and our sensors, I mean, everything that we have is sensor-based. So there are two questions. What makes the sensors that you work with different from the other products that we have, and how long have we had a standalone sensors division?
Okay, well, I'm going to answer the last question first.
Okay.
How long have sensors been around? We're actually LTI's newest division, the others being, as you mentioned, traffic safety, professional measurement, and sports optics. The sensor division is about 15 years old. The core laser technology that was designed to support traffic safety and sports optics was incorporated into the industrial laser sensor products. So, as you know, we're a time-of-flight laser system. For those in our audience that are unfamiliar with that concept, it's a technique for the known speed of light, which is a constant at about 186,000 miles a second, is precisely timed from the laser. So the laser sends out a laser pulse, and it's returned. That precise time on that constant of speed determines the distance to the object.
So, go ahead.
Okay, I'm sorry. Go ahead, Jenny.
Sorry. So we've talked about traffic safety, and we've talked about professional measurements already on Tuesdays at 2. So when we're talking about laser sensors, I know that you refer to them more in product families. Can you tell me how many different product families we have for laser sensors?
We have 3 distinct product families. We have the ULS, or what we call our universal laser sensor. We have the T-series, and we have the S-series. And each one of these sensors is built around a price performance point that is unique from the others. And the ULS, or the Universal Laser Sensor, as its name implies, is a general purpose laser sensor. It's our oldest sensor, it's our most capable sensor, and it's also our most expensive sensor. And the ULS is powerful because it contains the most capabilities in terms of range, accuracy, and data rate. The ULS can do things that other sensors just can't do. It also has a very wide number of firmware options for customers to be able to customize to their application. That also explains why it's our most expensive sensor. It's used in a variety of applications, from ship docking, hazardous cargo, to a variety of mining applications, to traffic applications. One particularly interesting application of ULS is using its return energy value, or the value of the energy returning off of an object that the laser pulse is reflecting off of, to determine if a pilot of a float plane is flying over land or water. The company that's developed this solution using ULS is called Whip Air. They're a company out of St. Paul, Minnesota, and they outfit float planes with special safety gear, helping pilots make landings over both water and land. And the ULS determines if the pilot is over water or land, compares that data to the status of their landing gear. Do they have their wheels up? Do they have their wheels down? If they have their wheels down, they need to be landing on land. If their wheels are up, they need to be landing over water. So the laser is a backup system to the primary system that sounds an alarm if it determines the conflict between what it sees as land or water and the right landing gear.
That is an amazing application.
It really is. They've done a lot of work to determine if they're over swampy water, clear water. They explained to me that, because I wasn't really sure of this. They said, well, having the right landing gear down is really important for the safety of floatplanes, because you'd think the pilot would know. They say, hey, we have a lot of pilots in the Caribbean islands, and they're flying from Florida to the Caribbean islands, ferrying passengers over. They're making 4 or 5 landings a day. And sometimes they just get a little bit, they're not paying 100% attention, they can have the wrong gear down, and this is a backup system that helps. And Whitbear said that when they first got our sensor, it was an option that they only put on planes where people wanted it. But over time, it proved so valuable, it is now standard equipment on all their float planes.
Wow, that's pretty amazing.
Yeah.
So what other kinds of problems have we solved with laser sensors?
Well, in the next family is the T-Series.
Okay.
This laser is designed to detect and measure the speed of moving vehicles. And before I get into the laser, I want to cover a couple of points I brought up a little bit earlier, and that is all sensors have 4 performance criteria, and those are range, accuracy, sampling rate, and cost. And usually these 4 capabilities are really trade-offs against each other, because when they're combined, they determine the best solution for a customer's application. So in some applications, they require short range but high accuracy. In others, they require very long range, but they can live with a lower accuracy. Still others require high sampling rates, but they can live with less range. In the case of the T-Series, it's all about high sample rate and short range. High sample rate means we want to see moving vehicles. We want to detect moving vehicles. We want to measure the distance to the moving vehicle. And these vehicles can be moving very fast. In some cases, over 100 miles an hour. So the sampling rate of the T-Series is 25,000 times a second. Compare that with ULS, where it's 2,000 times a second. So it's over 10 times faster. But what it gives up is the range is much shorter. Well, it doesn't have to be really long range. The trigger cameras and do things like the T-Series does. So we've used the T-Series for a lot of different traffic and vehicle detection systems. And in one instance, we paired the T-Series where we have two of them on a sensor bar, and it's used as an overnight traffic system. It's placed on the side of the road, and as trucks go down the road, it's measuring the height of the truck. And if it determines the height of the truck is over a certain amount, it sounds an alarm down the road for the sign to come on, warning the truck to stop because it's about to enter a tunnel.
Okay, yeah.
And sensors determine that if the truck enters a tunnel, bad things are going to happen.
I have no stuff. Yes, it is. Yeah, that's a useful thing.
Yeah, very useful. And according to the integrators that we worked that deployed this system, that happens more often than you think. Truckers they can read a sign that says, hey, you're about to enter an overheight situation, and if your load is over 13 feet in height, you got to stop now. But they don't often heed the warning or recognize it or whatever. So with an automated system set up that actually measures that, determines it, if there's been a load shift or something, it can really help warn the driver. And to keep the driver out of the tunnel, when drivers actually glide with the tunnel, sometimes it means the tunnel is taken out of action for weeks.
Yeah.
And traffic has to be rerouted, and this becomes a multi-$1,000, sometimes six-figure issue to repair. So spending a little money for a sensor warning system has quick payback versus having a collision like that.
I I can think of a few places where I grew up where this would have been very useful.
Yeah.
We would have semis get stuck under like a railroad bridge, and the height was high enough, but there was a dip in the road that went under it, so the length of the track was not okay.
Yeah.
And of course it was the one way to get from one side of the town to the other, so whenever traffic had to be rerouted, it was expensive and not good for anybody. So yeah.
Just one example of how the T-Series is used like that. Our final product category is called the S-Series. And the S-Series is now our biggest seller. And the S-Series is actually broken into two broader categories. One is what we call the S200 series, which is designed to measure solid targets, and the S300 series, which is designed to measure liquid targets.
Okay, what's the difference?
Okay, well, when you're measuring solid targets, you're looking at, obviously, a solid object. It can be something like level measurement for a solid object would be measuring grain in a silo. Corn, wheat, rice, that's a typical application for the S-Series. We have S-Series out in California that are measuring almonds and almond processing, where they're going in about 6 different bins between the time they're harvested in the orchard and they're processed and ready to be sent out to the factory. Because believe it or not, almonds are used for a variety of consumer products. I guess you'd think most people use almonds for like Blue Diamond. They put almonds in packages for people to eat, but they also grind them up, and they grind them up and they use them in various food things. But then they also grind them into fine powders, and they're used for things like cosmetics and all kinds of additives that you wouldn't think of. It's an organic additive. So the variety of uses for almonds is far-reaching, but our sensors are used for measuring almonds since they go through these different processes, and that's one example of many. We have another group that uses the S200 in a security application, and what they've done is they have a big wholesale car lot. It goes over a quarter mile in each direction, and they have a high fence with barbed wire across the top of the fence. There's generally people crawling over that barbed wire, getting in the parking lot, and breaking into cars. So now we have our laser system set up, the 200 is set up, mounted at each corner, shooting across the top of the fence. When the beam is broken, it sends an alarm out. And that alarm signals the security guards that something has broken that beam to be on the outlook. And the system can not only determine the beam has been broken, but because it can measure to that object, it can determine exactly where that beam was broken. Like if somebody is trying to enter it through the same opening every time, the sensor has the ability to detect that.
Oh, okay.
Another of many applications that the 200 is used for.
Okay, so what's so special about a liquid sensor then?
Well, the liquid sensor is really, it's oriented to look down at the top of liquids. It's measuring the liquid level, or the distance between the sensor to the liquid level. And there are 4 major categories we market our product into. Before I get into that, I'd like to explain why this is so such an accomplishment. And that's because in the past, lasers have been pretty good with measuring solid objects and not very good measuring liquid objects. And it's because liquid objects bring with them certain challenges of their own. The surface can be uneven, it can be rolling, it can be acting like a bendable mirror, it can be reflecting energy away from the laser, it can be turbulent, it can be clear, where the laser would tend to penetrate the surface and not detect it. So there were a lot of things going on, and we've been able to overcome all those with the S-Gritter line that we launched last year. And so the unique challenges of liquids, And we look down at the liquid surface, so we're mounted above it, looking parallel or looking perpendicular to the liquid surface. And regardless of whether that surface is rolling, whether it's turbulent, wavy, whether it's clear, cloudy, or opaque, we can measure, we can identify the surface and measure accurately to it with the 300 series. And I mentioned the categories. We've got 4 broad categories we market this into right now. And the first one is water, wastewater. And that's your typical water utilities and industrial wastewater. And so I think a lot of people are familiar with water utilities because they get their bill every month from the water utility that takes their wastewater from the bathroom and cleans it and turns it into drinkable water, and then it comes back through. And there's a series of tanks and processes that goes through at water utilities, and they use sensors throughout that entire process. And typically what they've done in the past is use contact sensors. And contact sensors are things like pressure sensors, float sensors, things like that. The problem with contact sensors and the reason why water utilities are trying to get away from them is, although they're cheaper, they're higher maintenance. So the initial cost is cheaper, but the cost to keep them, maintenance them, the total cost of ownership is higher.
Okay.
Imagine nobody wants to clean the sensor that's been in a sewage tank.
No.
And we actually heard water utilities that have to clean these twice a week. They have to take them out of the sewage tank. They have to have somebody wipe them down, wipe them off, so they're working again, and stick them back in the tank. And then they start detecting the level. And what they do in the level is, as these tanks go up and down, once they go up so far, they'll turn a pump on, and they'll start pumping that, and start sending it to another place. And then before it gets to the bottom, it turns the pump off. So it's using that data, that level information, to control pumps. And we're not contact sensors, so we sit at the top of all these tanks and vessels. We're not contacted with the water, so we eliminate that maintenance issue right there. And that's a big sell into that environment. So we're competing with ultrasonics and radar, which are 2 other non-contact sensing technologies. But ultrasonics bring with them a lot of limitations. And that's where we see our biggest traction right now in water and wastewater, is because ultrasonics just haven't been working well in those environments. They're sound waves. So they bounce off a lot of objects that are also in these vessels, hawks, ladders, things like that. They have to map all those out. The installation process is really tedious. Anything changes. If there's sound that comes from these pumps, they turn them on. Sometimes that can interfere with the sound waves coming back to the ultrasonic sensor. And they try and filter these out, but sometimes they're not very successful with that. So they run into a variety of limitations that we don't have issues with, because we're a light technology. We're not a sound technology. We don't care. We can work in a vacuum where they can't. So we have a lot of innate advantages with our technology in these environments. The second industry is chemicals processing. We have a lot of liquids there. Plastics of all types. You can imagine fertilizers, glass, liquid glass, all these different types of things that are liquid in nature that are going on in the chemicals processing world. Oil and gas, things like that. We can be in that market. The other major one is food and beverage. You can imagine all the soda and beer and wine, milk, salad oils, dressings, all those types of things. Those require sensors in the processing because they're liquid in nature. And then finally, the last one is flood management. And we have a lot of opportunities there. Matter of fact, we've got people from the Army Corps of Engineers and USGS testing our sensors right now. And from the initial results that have come back, they're very pleased.
That's great news.
Yeah.
So, what makes, you touched on this a little bit in comparing to the ultrasonic sensors, but what makes LTI sensors different from the other sensors that are on the market?
Well, there are several items. Number one is we've been developing sensors for over 35 years. So we developed this huge patent portfolio based on our sensor knowledge and know-how, and that goes into all our sensor designs. So we do really innovative things, and it really comes down to three concepts, and that's target discrimination, target acquisition, and target extraction. And target discrimination means, can I readily identify my intended target? And there are sensors out there, yeah, they can detect a reflective target in a controlled environment in a demonstration. But you take that sensor and you put it out in the real world where there are multiple targets around, and you're going to pick out that one target because that's your intended target and ignore all the others. That's where they have problems, and that's where we shine. Our ability to go out to a non-reflective target that you intend to measure to and bring that measurement back accurately, that's where our special algorithms and all our patents are applied into that. So we have the ability to really find those targets other people can't find and accurately return back. And that's called the target acquisition. Once we identify the target, can we measure to it, and then can we take that measurement and bring it back to the sensor? That's target extraction. So that's what those concepts mean. In lay terms, it means, can we get to the target, accurately measure it, and bring it back? And the answer more times than not is yes, we can.
Well, thanks so much for joining me today, Clint. Is there anything else that you want people to know about our sensors?
Well, I mean, there are certain places they can go to learn a lot more than what I've covered. We've got our own microsite for the S300. We have our corporate website that covers information as well. We're always adding to that content. So if you don't see something this month, you can always come back a little bit later. That's a good place to start. And obviously, once you peruse that information, if you have a specific application in mind, just give us a call.
Because you're always looking for new ways to solve problems.
We're looking for new ways to solve problems, and if we have what we think to be a really good solution for you, we'll tell you right up front. And we'll work with you to help solve that problem. Whether you're a systems integrator or an end user, it doesn't matter.
All right. Well, I want to thank everyone for spending some time with us today. If there are any questions that are posted on the recording of the video, we will pass those on to Clint as well.
Ruh-roh.